Hi guys, welcome to my channel. Today we will be talking about organic chemistry. Sadly, I had to retake organic chemistry too, but now that I am retaking it, I can see that I am able to help out my friends more who are struggling with it. If you're taking, I'm in a quarter system right now, so I'll have to take organic chemistry 3 later. But this is a hard class. And if you're struggling, that's okay. It's hard to understand. So what I want to talk about are Sn1 reactions. And this specific one came from my lab quiz. And I believe I actually did perform this in lab. So it's t-pentyl alcohol reacting with HCl to produce t-pentyl chloride. So this is what I have right here. I'll show you the mechanism later. So the reason we can say that this is an Sn1 reaction is that when this leaving group leaves, this will create a tertiary carbocation. Tertiary carbocations are the most stable. And secondly, this tertiary carbon right here is too sterically hindered for an Sn2 reaction. So Sn2 wouldn't even proceed. So you know that it would be Sn1. Additionally, with Sn1, those undergo carbocation intermediates. But Sn2 undergoes, or it has for its intermediate, and that's kind of a bad term to use it, they have transition states. Intermediates are, you can isolate them, and they do exist, but transition states in Sn2, they do not exist, but they're just there to serve as a model for us to propose why things react the way they do. So right here, you see we have an alcohol. An alcohol is a really bad leaving group. So what do we have to do in order to make it a good leaving group? Make it unstable. So here's what we do. This alcohol right here, the oxygen, I didn't draw in the lone pairs because quite honestly, I don't like to. But if that helps you understand, then please let me know in the comments what you would like to see in here so that you can better understand this. There are lone pairs on this oxygen because this is very electronegative, and those attack this proton right here. The reason why the protonation of this alcohol would make it a good leaving group is that, like what I said earlier, this extra oxygen or hydrogen makes this oxygen unstable. The reason, though, this oxygen is unstable is because it's in the group 6A. Meaning that it likes to feel like it wants to feel like it has 6 electrons. All these atoms need 8 valence electrons in order to be stable, unless they have a d orbital where they can overload the 8 valence electron. But it needs 8 valence electrons to be stable, but it wants to feel like it has 6 because it's in the group 6A. So how does it do that? It uses a combination of lone pairs and bonds. So here, the back of my notes, what I have is right here. So this is a very poorly drawn Lewis structure of oxygen. This looks like diethyl or dimethyl ether. But here, I'll just draw R's on there so that you can see where it's going. All right. Oxygen needs both a line or a bond and 2 lone pairs in order to feel like it has 6, but it does have 8 valence electrons. So for oxygen, it wants 2 lone pairs of electrons and 2 bonds because 2 lone pairs has the feel of 4. Lone pairs are 2 electrons at the cost of 2, but bonded electrons are 2 electrons at the cost of 1. So when you have 2 lone pairs, that's 1, 2, 3, 4, and then you have 2 bonds, 5, 6. And that fulfills what oxygen wants. So if it has anything else, if it has 3 bonds and 2 lone pairs, then you have, here, let me draw that one out where it would produce, let's say, like a hydronium ion. That one has an oxygen with 3 hydrogens attached to it and 1 lone pair. Now, like what I said earlier, a bond is 2 electrons at the cost of 1. So now you have an oxygen right here, and you have 1 lone pair, so 1, 2, and then 3 bonds. So you count each bond as 1. 1, 2, 3, 4, 5. And because that's less than 6, it has a charge of +1, a net charge of +1. So even on this one right here, it has a net charge of +1, making it unstable, and thus making it a good leaving group. Now, you know that oxygen is more electronegative than carbon. So if you make oxygen hungrier for electrons, then it's going to want to pull these electrons even more. So now you lose this leaving group right here as water, and now you produce a tertiary carbocation. And remember, tertiary carbocations are the most stable carbocations that you can have under benzylic carbocations. Those are the absolute most stable. But this one is in a non-pi conjugated, if I'm using the right terms, system. This one would be the most stable. And now, because remember you attacked this hydrogen or this proton and you kicked out its electrons, giving it to chlorine, now you have this extra chlorine hanging out. And now that can attack where it is positive right here. So chlorine has a -1 negative charge because it got both of the electrons there. And now it can attack this positive charge right here, making t-pentyl chloride. So that is what I have for you guys today. As you could probably see in my other notes on the back here, I will make a rearrangement video another time. Rearrangement can be tricky for hydride, alkyl, and methyl shifts. Just remember that with the reactions, they want to be as stable as possible. The reason the tertiary carbocation is the most stable is because it has, and this is how I think of it, 3 friends it can rely on. So if you're, let's say, if you're being really emotional and you're crying all the time, it really helps that you have friends that you can hold on to, that you can talk to, and they can support you while you are unstable at this time. However, if you were to have a primary carbocation which is so unstable that it doesn't exist, according to my professor, please tell me if I'm wrong. See, this guy has no one to hold on to. It has maybe that guy, but it's very, very, very unstable. While this is still unstable, it's not as unstable as this one because it has 3 other friends it can rely on, it can depend on for support. So remember, everything requires stability, and most often stability is when things are more connected with each other. I can make a theological argument on this. I have done this plenty of times at the dinner table. So if you guys have any questions, please let me know. Alright, have a good day, guys. Happy studying. Alright, bye.